Is humanity hurtling toward its own extinction? And if so, who bears the blame?
A 2025 study suggests that the quake could suddenly sink part of the Pacific Northwest, and climate-driven sea level rise would only make it worse.
The geologic record tells us that there are large earthquakes along that boundary about every 300 to 500 years.
Deep beneath the Pacific Ocean, two of Earth's tectonic plates are fracturing, triggering subduction zones that unleash earthquakes and volcanic eruptions. This is happening off the coast of Vancouver Island in the Cascadia region, where the Juan de Fuca and Explorer plates creep slowly beneath the North American plate. Since the dawn of the Industrial Revolution, humans have drilled deep, pumped fluids, and detonated nuclear devices within the Earth's crust thousands of times. We haven't just extracted resources, we've directly tampered with the planet's mechanical structure. In 2024, China drilled an ultra-deep 11-kilometer borehole in the Taklamakan Desert. In 2008, the filling of the Zipingpu Reservoir in Sichuan is believed to have triggered a cascade of stress that culminated in a devastating M7.9 earthquake. The consequences could be catastrophic. We may be inching toward a global chain reaction, where the Earth's tectonic systems recalibrate to restore balance, and when that happens, humanity could face obliteration.
We really need to be prepared for that eventuality, because it's not a matter of if, it's just a matter of when.
This isn't confined to China. From Nevada to the Taklamakan, humans have repeatedly pierced and shaken the Earth's crust. In the mid-20th century, 928 underground nuclear tests in Nevada left fractures stretching kilometers deep, still reverberating decades later. In 1989, the Soviet Union's Kola super-deep borehole reached over 12 kilometers, uncovering superpressurized fluids and extreme temperatures, ominous signs that the Earth was reacting to human intrusion. According to a 2025 PNSS report, over 1,200 industrial drilling sites have now penetrated seismically active layers, accompanied by a steady rise in global microquakes. These projects are turning our planet into a web of artificial wounds. And so, the question looms, is the Earth approaching a natural reset, or are we the ones destroying it? For decades, scientists insisted earthquakes were purely natural phenomena, beyond human influence. But since the early 21st century, empirical data has shattered that notion. We can trigger earthquakes not with weapons, but with the seemingly harmless technologies of modern industry. The most striking case is Oklahoma, USA. Between 2006 and 2016, this state, once outside any seismic belt, saw earthquakes of magnitude 3 skyrocket from a few dozen to over 1,000 annually. These quakes clustered around wells injecting wastewater from fracking, a process that pumps millions of liters of water, sand, and chemicals into the ground to fracture shale. USGS data reveals an undeniable correlation between injection volumes and seismic frequency. When the wells were shut down, earthquake rates plummeted. This is no longer a theory, it's clear evidence of cause and effect. Similar patterns emerged in Texas and New Mexico between 2013 and 2018 in the Permian and Eagle Ford oil and gas fields. Seismic data shows ancient, stable faults dormant for millions of years suddenly reactivating. Small quakes, M2, M4, struck weekly, and some areas were flagged as induced seismicity hotspots by state geological surveys. Several companies were forced to halt operations after regulators confirmed direct links between injection and tremors. It's not just dirty extraction causing consequences. In Groningen, Netherlands renowned for its high-tech and safety standards, a parallel story unfolded between 2016 and 2020. Decades of natural gas extraction caused the ground to subside by over 30 centimeters, triggering hundreds of small quakes that damaged thousands of homes. The Dutch government was forced to shut down the Groningen field, ending a project that once supplied 10% of Europe's gas. But the most alarming revelation is that even renewable energy projects touted as green and safe aren't exempt. Between 2017 and 2021, geothermal projects in Basel, Switzerland, and Pohang, South Korea, triggered M5 earthquakes, causing millions in damages, in both cases. Injecting superheated water into deep rock layers increased pore pressure, causing latent faults to slip abruptly. Though these quakes released energy thousands of times smaller than natural ones, the amplified effects within fault systems far exceeded predictions. From Oklahoma to Groningen, from oil fields to geothermal plants, a pattern emerges wherever humans pump, inject, or extract fluids from the Earth. Tremors inevitably follow. The Earth is no longer a closed system, it responds, adjusts, and releases energy in ways no one can control. And here lies the greatest paradox: the very technologies deemed green and safe are destabilizing the planet. Let's shift to the lens of geophysics. Every fault system has a critical stress threshold. Beyond this point, even a slight change in pore pressure, the pressure of fluids within rock grains, can cause the entire system to slip. Right now, humans are driving those subtle yet globally impactful changes. The 2008 M7.9 Sichuan earthquake is a chilling example. Just 5 kilometers from the epicenter stood the Zipingpu Dam, holding over 300 million tons of water. Coulomb stress transfer models, published by the Chinese Academy of Sciences, showed that the reservoir's filling increased pore pressure on nearby faults by 0.10.2 MPa, enough to push the system past its equilibrium. Before this, the region was considered seismically stable, but when the load shifted abruptly, the crust reacted instantly. The timing between the reservoir's filling and the quake forced many seismologists to concede human activity can catalyze natural disasters. From 2019 to 2022, data from China's deep drilling projects in Tarim and Songliao reinforce this view. Stress sensors embedded in rock layers 7 to 10 kilometers deep recorded stress redistribution after test fluid injections. Some sites showed local stress increases double the predicted levels, revealing the crust's hypersensitivity to human interference. Simulations published in PNAS and Nature Geoscience between 2023 and 2025 go further, demonstrating that human-induced stress can propagate across regions. A single well or massive reservoir can trigger a fault hundreds of kilometers away through the diffusion of fluid pressure in interconnected rock layers. When human pressure surpasses natural thresholds, the planet no longer responds locally, it recalibrates globally. What was once deemed technically safe may now be the spark for a cascade of tectonic events. If this trend continues, the Earth may be approaching a new threshold, where every human intervention leaves a seismic mark. Faced with these events, the scientific community is divided. One side argues humans only cause minor tremors. The other warns we've unleashed an entirely new tectonic mechanism. Agencies like the USGS, CNPC, and ETH Zurich maintain that induced seismicity earthquakes caused by humans is localized and rarely exceeds M6. They argue that human-generated energy is thousands of times weaker than the natural forces accumulated over millions of years. From this perspective, tremors near industrial sites, oil wells, or geothermal plants are mere temporary mechanical disturbances, incapable of continental-scale disruption, but a growing vocal minority disagrees. Geophysicists like Egil Hauksson of Caltech and Mark Zobak of Stanford caution, even tiny injections can trigger critically stressed faults. The issue, they argue, isn't the absolute energy, but the delicate balance of fault systems. When a fault is near its tipping point, a slight change in pressure or subsurface flow can collapse the entire structure. We're not creating earthquakes, Zobak says. We're knocking on the doors of faults already primed to slip. The divide deepens with meta-analyses in Nature Geoscience and PNAS 2023-2025. Global statistics show a tenfold rise in human-induced quakes over 2 decades, with non-seismic regions from Texas to the Netherlands to northern China now hotspots of geological activity. This data contradicts mainstream models, which can't explain the global surge. As empirical evidence outpaces theory, the line between orthodox science and Gaia-like warnings blurs. One side clings to technical control, the other sees the Earth as a living system, self-regulating and retaliating. Regardless of the stance, one truth is undeniable: we've underestimated our own impact, and we may be underestimating the planet's capacity to fight back. In biology, every living organism responds to injury with reflexes, inflammation, fever, tissue restructuring, defensive processes to restore balance. If we view the planet as a vast biological system, something similar is unfolding. The Earth is reacting to human-inflicted wounds not with vengeance, but with self-regulation. The Gaia hypothesis, proposed by James Lovelock and Lynn Margulis in the 1970s, posits that the lithosphere, atmosphere, and biosphere operate as a unified organism, capable of maintaining its own stability. When one part is disrupted, chemical imbalances in the atmosphere or excessive surface warming, other parts respond to restore equilibrium. Now, those responses are emerging in concert: rising seismic activity, magnetic pole shifts, polar ice melt, and global climate change. Scientists note uncanny alignments among seemingly unrelated phenomena: increased volcanism along the Pacific Ring of Fire, anomalous seismic wave propagation, rapid shifts in the Earth's rotational axis, and unprecedented ice melt in Greenland and Antarctica. Through a biological systemic lens, these could be the planet's natural reflexes when strained by extraction. Deep drilling and human-driven climate change. The Earth fevers to expel the disturbance. Like a human body fighting infection, the planet's response comes at a cost. Earthquakes, tsunamis, volcanic eruptions, and extreme weather may be inevitable byproducts of this self-balancing process. The Earth isn't trying to destroy humanity. It's trying to heal itself. And, inadvertently, the source of its wounds. Human civilization may be the one eradicated. If Gaia is indeed a living system, we may be witnessing its immune response, a desperate bid to restore balance at any cost. The question remains, will we have time to adapt? Or will we be swept away in the planet's attempt to heal the very home we inhabit? For billions of years, only three forces shaped the planet's surface: volcanism, glaciation, and meteor impacts. Now, a fourth has emerged: humanity itself. Research published in Nature Geoscience in 2025 formally introduced a new concept: anthropogenic tectonics driven by humans. Data from thousands of seismic stations reveal new fault systems forming around major industrial zones. From North America to Europe to China, ancient tectonic plates, once governed by natural rhythms, are now disrupted by global drilling, injection, extraction, and construction. The planet is no longer a stage, it's a vast experimental subject for our civilization. Statistics show that the annual seismic energy generated by human activities: nuclear tests, oil and gas extraction, fracking, and geothermal projects now surpasses the natural energy of some microcontinents. These vibrations don't just ripple locally, they propagate through active fault systems, altering global stress patterns. Geophysicists warn if this continues, humans will become a true tectonic force, shaping geological evolution for millennia. A team at ETH Zurich has even proposed a new term: the human-driven crustal phase, a geological epoch dominated by human influence. Beyond altering climate or ecosystems, we're rewriting the Earth's physical structure, processes once tied to natural cycles: continental uplift, magma eruptions. Plate shifts can now be triggered by human technology. But with this power comes unprecedented risk, as humanity emerges as a tectonic species. The question is no longer whether we can spark geological upheaval, but whether we can control it. If the Earth is truly entering the Anthropocene, an era driven by humans, it's not just a historical phase, it's a verdict on the survival of our civilization. For when we place ourselves on par with nature's forces, even our smallest misstep could unleash a planetary catastrophe.